Okay.
Recording started.
Okay, great. So, yes, go ahead.
Are you talking about VMware and ESX and stuff like that? Or?
And stuff like that, yes. So, my name is Tim Ryan. I'm the Technical Operations Manager at City College of San Francisco, which is one of your host colleges here. And I have a unique role. I actually work full-time in our IT department. And I have an engineering background, and I've been working in the field of IT for about 20 years. But I'm also a co-PI on the MPIC grant. So I started working with PR Theory about 6 years ago, and we brainstormed and applied for grants, and we started as a ATE project, and now we've become an ATE center as of about 3 years ago, and hope to have an extension of the MPIC Center. So I don't teach necessarily in the community college environment, although I have some teaching background and some teaching experience. So primarily what I do and what this presentation is about is how we take the technologies that we've learned. It builds on some of the other topics that have been presented here today. And we essentially apply that technology as would any business, pretty much, school, hospital, bank, etc. So we end up with kind of a microcosm of pretty much every type of technology that is developed, we've implemented in some fashion or another. And then the things I always try to bring back upon is, well, what skills are needed to do it? What jobs does this equate to for students? That kind of thing. So that's where I'm going to focus some of my efforts. But a lot of this is going to be kind of what I call the design and deployment of this virtualization technology. So I'm going to start with a definition of desktop virtualization. And this is a very fluid field. There's a lot of different ways to implement a virtual desktop, a lot of definitions. This is the definition that I found from PC Magazine. So we'll kind of go with this, but it uses a lot of terms. It right away starts with the term thin client, which is something we're going to be discussing a little bit. Talks about virtual machines, etc. But basically, it's something other than the traditional PC that we've known for decades that we've worked with in our offices and in our lab environments. So it's evolving. It's certainly not going away completely. It's an evolution of technology, but it's a huge business. So HP alone, they talked recently about spinning off their business, and then they're not spinning it off, and then who knows what they're doing. But it's a $40 billion a year business. So some of the employees, we were asking them, are you concerned of being spun off? They go, what are we concerned? We're going to be either a $100 billion business or a $40 billion business. Either way, they have a very valid market share with this technology. But my point is today is to show you how this is evolving over time. So definitely, no matter which path you take, a virtual desktop infrastructure consists of these components. You still have a traditional keyboard, monitor, mouse. You have then some type of integration device. And I'm going to be passing this around in a minute. This is the particular integration device that we use. But you have to connect the keyboard and monitor and mouse together somehow. And then you have things, connection brokers. You have a manager, a virtual desktop manager. You have virtual machines. So instead of the computer being in front of you, it has to exist somewhere. So it's a virtual machine that exists in a server environment, which I'll describe. You have images. Now you have to have an image built of your applications. And then these all have to reside on physical servers. And then what now is your hard drive, or has been your hard drive in the traditional model, is now going to be a storage area network in this virtualized model. So there's a couple different virtual architectures, and I see my changes didn't get incorporated in here. But in any case, we have a zero client environment, which zero client means if you don't have, there's no local operating systems. So that's typically what's defined as a zero client. So an example is Panalogic, which is the one we use. There's Wise Technology, others out there. You also then have the thin client, where there is actually a local operating system on the client. So HP, Dell, a lot of vendors have that type of technology in place. I hope that's not the fire alarm to evacuate the building. It is. Great. All right. Well, let me jump to the conclusion slide, just in case. You look at all these things you're going to miss. No. There you are. The desktop, the summary page. You have faster deployment. Good. Okay. All right. Well. Okay. You get to see everything here. They're just keeping us on our toes. All right. So anyway,
Is it posted somewhere?
yeah, these slides will be posted, and this is all recorded. So, sorry. Yeah, we don't have to evacuate the building. So back to our topic of virtualization. There's another model here that I want to present, and you've heard a lot about cloud computing. So there is actually a model that at least I envision, whereby all of this would be hosted in a public cloud service. So Amazon.com, for example, they, what we're really doing is just creating a virtual machine somewhere, and we're doing it in a private cloud at some expense. But if you do it in a public cloud, right now Amazon charges 10 cents per hour for a Windows machine in their virtual environment. So, ideally you would have the, by the time your lab environments, this is what typically is for a computer lab, you might only have it, 8 hours a day or something like that. So ideally you'd be paying, say, 80 cents a day. But you have to pay 24 hours. It's a huge setup time. This is very complicated. It really would take you right now about a month to set this up in a virtual environment. So you can't just walk into the room and turn it on. I mean, we have problems just getting the projector to work, the microphone, the lights, fire alarms. So, our classroom, it isn't something that you just turn on. But it may get to that point at some time in the future. But right now, if it is 10 cents an hour over a year period, that's about $800 a year, every year. So, that isn't cost effective. You can buy a whole computer for that much and use it for some number of years. But definitely it is down the road, yes.
I mean, how many people could be using that if it were in the cloud?
As many as you pay for at 10 cents per hour.
Per person?
Per person, yeah, per computer, yes. So, yeah, so $800 a year per computer. Well, no, not per hour. I mean, that's the thing, per usage hour, but you have to get everything installed and set up. So if you take it down, and maybe you can turn it off virtually, but then you would have to reconfigure and rebuild it all up again. It isn't going to be necessarily that easy to turn on again. But if you just want a basic Windows server, sure. But if you want all your applications that you're teaching with, that's something different that you would actually have to build and set up over time and maintain it. So anyway, I think that's maybe another iteration of this technology. Okay, I have a suggestion. Happy hour, we can start. Yes. We meet off the corner, on the corner, where we have last year. Everything that's necessary to begin our. I think it's reception event.
Like once today,
So if we're getting all this on computer, I want to make sure we got all that. Okay, well.
You were right.
Happy hour, yes. About $100.
yeah.
Sorry about that.
That's okay.
Yeah, you got cards?
false alarm. Please ensure the rest of your day.
I think it's about $100 for the panel device, but you know it's misleading. You need storage area networks. You need all kinds of stuff. Anyway, my changes didn't actually get put on here. Why the hell not?
The device and the monitors and everything.
Yeah, right. You need all that stuff.
You can actually plug in USB devices and stuff like that.
Yes. God damn it. Shit. Sounds good. Added budget.
So why did they decide to build this system?
Well, our CTO, you know, envisions this as being the future of the computing environment,
Right.
and that, you know, there's the benefits are,
I mentioned this
you know,
on campus. I mean, is there any support or anything like that by using the system?
well, yeah. So there are overall there's lower support costs. I mean, that's the whole goal is with the 400 computers there that we envision. In a normal environment, it might be 2 lab techs full time, and the goal would be to reduce that. But it's the broader in scope. We have 5,000 computers in our campus, so you can't look at an individual set of 400 and completely extrapolate it. But that is the goal, so it just it ends up being with you have lower support costs and reduced deployment time and that kind of thing. And then the panel logic is just one piece of that. So
I remember, and this was probably about 14 years ago, Sun came out with a box that had a card attached to it. Right?
yeah, so the dumb PC or something like that, dumb client, just a client.
It was kind of like a license and all, but this card was your key to get in, and the system recognized the card.
Yeah.
If you unplugged it from one device, went across town and plugged it into another device, your desktop internet would come right up where you had left off.
Yeah.
And so it seemed nice at that point. They were talking about for education, you could actually take the cards in both for like $1.
Yeah.
But,
so the whole cloud thing, I mean, it's really dependent on all your network connection to your service provider. That you need to add capacity to that, maybe redundancy to that.
for a local area network, if you're getting 100 or gigabit between buildings and
yeah, between buildings that's easy, but a cloud provider is hosted out somewhere else, you don't even know where it is. The distance makes a big difference.
campus, it might be ideal.
Yeah, you build a private cloud down on your main campus and redistribute. We have a great network here around the city, but something that's in a public hosted cloud, you don't know really where it is. It may be close, may not be, that kind of thing. So that's one aspect to it. This is the block diagram for the Panalogic thing. So it has audio and USB subsystems and things like that. So anyway, I'll post these or send these out. If you have a card, I'll send it to you. Okay. But anyway, so HP basically same clients. They do you can't quite read it. They do mainstream thin clients and then flexible thin clients and specialty thin clients and there's all different kinds.
I have a Weiss one.
Yeah.
Keep getting it, and there's probably a power supply.
Uh-huh.
And the Sun ones were very impressive, but I don't think those exist anymore.
Yeah. This is all the pieces we had to put in place.
The thing I liked about the Sun ones when they came out was you didn't have to use Sun's server in here. They would actually run with a Linux server, which I was thinking they would leave the cost to be almost like
These are some of the tech issues we encountered. Well, we train, of course. But you got to look at flow mouse response, you have to add CPU. The print application we had to play around with a little bit. But the whole application virtualization is unique for each app. It isn't just a magic thing. Some apps may not be able to virtualize. You know, if you have across the college, you might have 20, 30 apps, Photoshop and Packet Tracer and all that stuff.
Well, some of our labs, some labs like Word the entire week, and then some like a different lab.
Yeah. Also, there's no local TCP staff on these things because it's offline. So you can't. Well, you have an LED indicator on the box.
That's it.
So yeah. So it takes a little getting used to. People are like, you like to ping stuff.
Oh yeah. Make sure you get.
Yeah. So we're still learning a lot of the things. And then there is this whole scalability thing.
Now, does it use regular TCP/IP to get the information back and forth?
You know, I think it uses the PC over IP. I'm not sure. There's not TCP/IP running on this thing, so I don't know exactly what it does. It might be proprietary. Did they tell people to come back up once you got there?
Yeah, security guard. Well, what's the text?
But some people.
Triggers the fire alarm.
They were saying a lot of through a fire exit door, or pardon? I guess either somebody from the mall went through a fire exit door, or somebody from here went through a fire exit door. That seemed to be you heard. That's what I heard people talking about.
Okay. Now what?
Sure, jump in. Anyway, I'm going through if there's a specific question. I was just dealing with some of these issues we face. With our pilot, we did just 3 physical servers, and with the goal of being able to accommodate 120 desktops. So as you can see, this just isn't going to scale. I mean, these are all connections into Ethernet switches, this dependency and things like that. So that just didn't scale with hard servers like that. So we're going now to a blade server environment, which has a much better. HP does a great job with their blade server. And then this is our Chinatown campus. Yeah, it's not a very good photo. It's a webcam. Anyway, 16-story tower over by the Transamerica Pyramid in that neighborhood. So, and then this 4-story annex down here. So it's a $100 million investment as a part of City College. It's going to open up in the summer. Taxpayer funded, of course, funded. But these are the labs. So 10 labs that potentially we may use the number of desktops within the lab.
So you're going to do almost all of those?
Well, potentially. It's still kind of being discussed, debated, etc., but potentially. But, there's no reason. Again, we have 75 labs at our college. So whether we do these 10 right away or, when do you're never going to, they're all at various stages, of longevity. Desktop tech, I would say there's about 15. There's 75 labs. Yeah, the Cube.
Now, are they all under one organization? Or
Yeah, they're primarily under one organization. There's things. We're the biggest system. So being a centralized department, that's the best you can hope for. You want to be the biggest system. But yeah, it's not, we all know each other every day, or see each other every day. We've known each other for years.
Not so bad.
The reporting structure isn't all that relevant. They just like to work together. They all share knowledge and information, and
so let's just try it again.
Yeah. So we're jumping in here. We have time, and so anyway, that's the actual physical connection device.
So you rolled this out where?
On our main campus. This is what ended up being our pilot deployment.
Which campus is that?
Our Ocean campus, the one where you go for the winter, Happy Development Weeks.
The summer one.
Summer one. And
all right. City College of San Francisco.
Correct. It's here. Yeah. So we just tell them that we have 75 labs. Roughly about 3,000 computers in the labs and 2,000 computers on desktops. So our strategy is to find the right model for the future of desktops. We can't keep buying all 5,000. Well, that particular thing costs less than $100. But look what you have behind it. You have Citrix, you have Zen, you still have the monitor keyboard.
So you're doing Citrix.
We use partially Citrix, but VMware, Panel is the primary connection broker.
Right.
That's Panel, so Channel Manager. Yeah. Anyway, but you need a physical server. Storage area. I changed it to
So you need this desktop rollout, kind of case or something?
yeah, correct. And you typically allocate and there's this whole concept of persistent versus non-persistent.
Right.
Meaning persistent means it's continually on, and that seems to be the best approach. But we're still now experimenting with how can you really get that economy of scale. I mean, we only have 3 servers, so it's designed right now for 120 desktops, but we'd love to have 200 on there.
We like provision your labs in the morning, keep them on, shut them down at 10 or whatever?
Yeah, you turn them on. Well, we try to just pretty much with these ones keep them on all the time. That's the goal.
With these guys? Really?
Yes.
24/7?
24/7, yeah. Because they use very little power out of there. So you want to just keep everything. All this runs in the data center.
This says 5 volts.
5 volts. It's 3 watts.
Desktop say provision. Why do you need just Windows or Linux and Windows?
Oh, right now just Windows.
Just Windows?
Yeah, we run Windows XP. We're just working on a Windows 7 image.
So why would you run these 24/7? Because they have trouble.
Well, yeah, apparently when you boot them, again, we're still experimenting, but it's been recommended. You can boot them up, you can get like a virtualization storm effect if everything tries to connect back at the same time.
Oh, okay.
Because, if you walk into all the labs, you turn them all on. Turn them all on at once, yeah. And there isn't even an on-off switch on these either.
There's not much of one.
So that's another reason to leave it on.
How much power
It's an LED. It's very little power.
Okay.
So the main thing is, it's deceiving because this is very simple and generally speaking, our chances of someone to look, oh yeah, great idea. Well, they don't realize, you don't know how much work it is to set all this stuff up and keep it running.
Yeah.
Retrain the desktops or the desktop technicians, and sure, eventually we'll end up with fewer staff, but I mean, we have to always do more with less anyway. People retire, we don't hire any new. So it's not a big radical change. It's kind of a gradual rollout and a gradual shift in skills and responsibilities and things like that. So
what's the TCO on this compared to TCO on this connected?
well, that Amazon thing, I was being a little sarcastic there. I don't even know if you could really do that. You have to get all your apps up in Amazon. It takes a long time to load. Assume you have a lab environment that's shared by different departments, or you have something other than Windows Office in there, and or Microsoft Office. You got a lot of apps, so you got to set those all up. Yeah, but even still, to connect to Amazon, you need something still on your desktop. You got the monitor, the keyboard, the mouse. Something has to connect there. You need a thin client at least, and then HP has these various thin client systems. So HP or Dell, whoever, you're still getting something. This is a zero client, but no operating system.
You're buying an HP with a thumb drive on the system board.
Yeah, you buy it with varying costs, $250 minimum, for a thin client. I mean, a full computer is only $700 or $600 or something like that, just that. So anyway, we're doing a very impromptu presentation. Very. And then my goal here was to show that this is kind of the architecture of that system. So you have a subsystem for audio. You can still plug in a headset. You can still do the USB subsystem. You have the display network. So there's those things kind of built into that particular device. It's just not an operating system. And as I was explaining, you can't ping it now. You can't ping this thing. There's no TCP/IP on there. So that changes our dynamic a little bit in terms of our support and structure. And
there's not actually a CPU in here?
I wouldn't call it a CPU. There's a few chips. There must be something. I wouldn't say there's no CPU. There is no CPU and no memory.
It's an extremely smart.
So there's some type of a ROM, most likely.
Okay.
There's some read-only memory with some very basic some light.
Well, it has to have.
It has something on it, but there's no IP stack, there's no operating system, there's no CPU, there's no memory. That's all in the background in the other environment. So that's that block diagram with that, and then again, this is what we deployed. And so right now we have about 30 really active, and we're kind of growing. And then a combination of lab and staff, which is different because the lab PCs are on one side of the firewall, very limited access to resources, essentially just the internet. And our admin side, you can get to our banner application, you can get to your internal email. So big distinction there when it actually comes to deploying it and planning this out. And do it. Plus our staff members want to go from computer to computer and log in. You want to go from a real computer to your virtual computer and see, I'm here at this campus now, I want to log in and I want to get all my folder, my files. And that's a big change. Just that intuitive thing on their end is a big change from an engineering standpoint on how we set this up. So unless everything's all set, then it's more universal. But to go from a zero client to a traditional desktop and expect them to all look the same way, that isn't quite.
Mobile home directory.
Yeah, it's a little more of a challenge. We could if we made that our focus, but. So then this is just kind of an example of to the VMware. So these servers are running in VMware. So you still eventually want to see, well, what are the physical servers that this runs on? So there's 3 of them in this kind of a cluster. And there's some level of redundancy within that cluster, but pretty much that we need all 3 of them to run the 120 desktops. So instead of 120 lab computers or desktops, you now have 3 servers.
How much do the servers cost?
Well, these are traditional ProLiant servers, probably like 5K, 4 or 5K, something like that. But the big cost is the storage area network. And we had to allocate roughly 10 terabytes. So when everything that used to be on your C drive is now in the storage area network.
Yeah, we're fronting that bandwidth.
That's what these
are not much.
Yeah, that's what this is essentially the front. There's the physical servers, and then the various layers of software that allow access to that storage area network and to the C drive. And so the applications, everything, your file, everything is on the C drive. There's no data essentially on the servers.
Okay, so what I meant was, are you putting those terabyte drives in these servers here, or are you putting them with a box?
Yeah, these are the front to the storage area network.
So there's the storage area network is a separate box.
Yeah, storage area network is a separate box. Yeah.
So what kind of box are you using?
We use HP. It's called left-hand SAN.
Okay,
They
so
buy the company left-hand.
that's what the dollars are.
Yeah. Well, as long as they're here,
licenses.
licenses. I don't know about 70. They're spend a lot of money. It's easy to spend the storage area network to get it in place with 100K.
It's the front, the box on the front that's the dollar.
Yeah. Well, I think the drives can add up too, and there's licenses and HP SANs isn't.
It's not like you're selling drives and fries. I mean, they can charge a whole bunch of extra stuff.
Exactly. So SANs are a complicated environment. We just recently had that in place. And so this is just some other examples of this is now what our desktop technicians see.
Oh, wow.
And now they've had to be retrained to be virtual server, virtual machine technicians, essentially. And so all of these are the virtual machines that we deploy. Some are powered off, but a lot of powered on. You give it a host name, you have provided space, it has CPU, it has memory. So they're all now the virtual machine. It's no longer a real physical desktop. And then this is just a little more detail. You can click on that and dig into to see the actual, here's your operating system, the version, the CPU, memory, etc. So you see we have a gig of memory that we've assigned to these. CPU, I think there's only one, I'm not sure what that's, we had to add
CPU.
Yeah, that's one virtual CPU, but we had to change its virtual CPU size because just essentially a single core CPU wasn't quite enough. We essentially made it a kind of a dual core CPU. But again, the key question is how does this all aggregate? What kind of economy of scale do you get, eventually? So out of those 3 physical servers, you really want more than 120 desktops, especially if they're not all used at once.
Yeah.
I think it was, so we don't know quite yet what the design limitations are or what negative effects you're going to experience if you have all 120 active at once or even 180 active at once. And if that looks fine, well, let's go to 360 active at once, and see where you can really grow this.
Now, in the old world, you might have said, okay, this particular lab, computer science, is not going to be using Adobe CS5. So I'm going to provision these devices in here with, 100 gig drive, 1 gig RAM, blah, blah. And then over here in the media lab, I'm going to provision these guys with 8 gigs, 500 gig drive, because they're storing videos, blah, blah. And that's your plan.
Yeah.
If you put these in everywhere, are you saying that you've got to provision, like for the media lab CPUs, for anybody that logs on from anywhere, or that you have a way of understanding this guy's logging on from CS?
Well,
So I'm going to
These are going to be allocated, yeah, these have a physical name. So this system has a physical name, and this physical box is
they're
allocated.
logging in from the CS lab. I'm going to give them a CS image, which is positioned this way.
Right.
Here, they're logging in from the media lab. I'm going to give them
Right.
a media image, which is
Right.
positioned that way.
Yeah, so right now we've done it lab by lab. We haven't done it based on logging. Our students don't even have a unique lab log on
Right.
necessarily. Also, they don't store data on our systems. We don't have a data storage for students. We do for our faculty staff, with home directories and shared drives. But for the students, 100,000 students, where's your homework? It's their problem. The memory sticks are what they need to do to keep all their information on. And then the thing that we really want to look for is the network management. So now all of that data that used to be on the PC bus, that would go from the monitor to the C drive, now that all traverses the network. And so, because now that's all going from the display back to the storage area network. So that's what we really want to track. So this is a partial track of that. See 200 meg, 250 meg, what normally would be really small network traffic. We have a gigabit network everywhere.
Oh, okay, all right.
So yeah, that's a pretty almost every switch. It's been that way for a couple of years now. And most of the time the utilization is.
Are these gig NICs?
Those are gig NICs, yes.
Yeah.
Yeah. So yeah, that's a good question because we need to verify that. So we're just kind of watching. This is aggregated though. This is from the servers to that storage area network. So that's what we need to keep our eye on, because that's where that data is going, from all the displays, the 100-odd displays to the storage area network. So from 100 monitors to 100 C drives, how much data did that used to, was that in the traditional world?
We're sort of curious about your decision-making approach, because there's sort of two ways of looking at it. I'm going to have my vSphere boxes each have 6 slots, each has a terabyte in each slot. Or I'm just going to have my servers that are maxed out with RAM and CPUs, and then I'm going to have all my storage on another box.
Right. We have all the storage on another box.
Two ways of looking at that.
Yeah.
One is you're using the bus inside for your data transmission. But then you maybe don't have the flexibility you do with SAN as far as providing lots of storage.
So I'll show you the SAN, because we're not going to have a totally different campus with this technology. So I'll show that in a minute.
Gigabit?
Yeah. So here's some of the tech issues. Like I mentioned, we had to retrain the support desktop tech. We had some slow mouse response at CPU. We had to print application, took a little effort. But typically, application virtualization is a unique process for each app.
There's no way.
Okay, thank you. Thank you.
Whether the devices are.
Well, we can look at the management tool. We can look at the interface of the Ethernet switch and see that it's up. We'll see green. Also, this turns blue when it's a healthy network connection. If it's flashing amber, there's no network connection. So, but we can't tell that remotely. So the desktop tech has to either be there, or some of the calls has to be there to see it.
Right.
But
MAC address.
it does have a MAC address. So
what does it look like on a Wireshark trace across that connection?
we haven't really looked at that, but the source, it's going to have a source MAC address with the Wireshark trace. And we could see that MAC address, but again, now you've got to know, all right, well, which, you can't tell barely from here, I guess. Yeah, there's no MAC address on here. So you can't tell, how some devices, laptops have their MAC address on them or NIC cards. So we're still struggling with that issue a little bit. But, if it's working, that's not an issue. But you're right, the troubleshooting methods now, that we have to evolve a little bit, and we have to get a little bit more familiarity with it. So I can see how that could be an issue.
So your troubleshooting is going to involve port scanning there,
and
then looking at that like with Wireshark or something, and looking at the layer 2 traffic.
Yeah, well, we're thinking now, the issue that we've seen, it's an all or nothing. It's all in the back end is where we kind of expect there to be some issues. And so the scalability isn't really there, at least with the current model. So we have these 3 servers, each with some number of connections. There's redundancy within each, etc. But just 3 servers have 18 network interfaces. So that just doesn't scale. And this is only handle 120 devices. So if we want to handle 1,200 devices, this would all be times 10. we'd have 180 network interfaces.
So these servers are rack servers?
Yeah, those are traditional rack servers. Yeah. So one of our lessons learned was to get the blade environment, which I'm going to show in a minute. And then this is our Chinatown campus opening up sometime soon. This is the lab environment there, and as I mentioned, we're opening in June, so we're still evaluating whether this is the right approach for that. As a fallback, you go back to traditional desktops that everyone's familiar with. It's a pretty secure fallback plan. And then again, do we really need to start with this campus? Do we want to go somewhere else? We've got 75 labs. This is only 10 of the 75. We've got plenty of others to work with. In fact, I think we're going from now an environment of about 5 labs at the existing campus to 10. So we're going from 75 to 80 labs at this campus again. So we actually hope to have one of our faculty development weeks or something here. It's over by the Transamerica Pyramid, right next to Chinatown. Very nice neighborhood. Very lively. So another improvement that we would want to make, though, is use a tool called Unidesk. And what that does is it allows your image creation to be much more streamlined and much easier to deal with, because that's what the biggest challenge are. You have to virtualize the applications, and some of them may or may not have ever been virtualized by anyone else if it's a unique app that you use. Packet Tracer, that's probably been done, but if you have some other application within your environment that your instructors love and your students love, now you got to get it into a virtual world, and that's not necessarily easy.
And combos of things played fine while you were in desktop environment.
Yeah.
And they may not play together.
Right.
So you need to separate them into different VMs.
Right. And some have different memory requirements, different Java, etc. And also this then allows you to have the end result of this, an improved graph virtualization, is a lower SAN footprint. So less SAN space, which is a cost saving because that's a big part of your budget. And then HP has this Flex 10 now in their Blade server environment. So instead of individual NIC cards, you aggregate everything across this Flex 10 environment, and you can scale it. It can go from 1 gig to 10 gig. You can get essentially a 1 gig gigabit, and just pop that out, and you 10 gig. Then you have to your switch infrastructure has to upgrade as well. But that's our whole goal. Where we haven't put in 10 gig yet because, like I said, most of the utilization on our ports is like this, 1%. So of a gig. And so now this is one environment where we really have to keep an eye on that, because of that data going from the display back to the SAN, which used to go from the display to the C drive, times 100 or 1,000, what that can look like. So we really needed this environment to scale up. And this is HP's biggest selling product right now. Their Blade chassis and with the Flex 10 interface.
So you're looking at port per 10 users like you've got your drawing board.
Yeah.
6 ports per box, which supports 60 users on that box.
Yeah, it wasn't.
3 boxes for 180.
But some of them were there just as redundant connections and things like that. So this way, by just having 2 Flex 10 interface, 2 10 gig interfaces, you'd have all your traffic across them. You'd have one there as a backup where you could load balance it. So it's really a good model that HP's come up with. This is a whole new network paradigm too. So our network team has to learn all this, figure out how this stuff all works.
One of those doesn't go down.
Yeah, no, it wouldn't. But you have redundancy, whether it's automated failover or some other thing like that. But you end up with so much redundancy, it gets confusing. You can start to create spanning tree loops and things like that, where all your layers of redundancy cause problems that you wouldn't have experienced if you hadn't tried to make it redundant. That happens too. And power is still the biggest problem there. And there's not just the thoughts where UPS is at failed, but circuit breakers are tripped, and then PG&E, shuts off power on a Monday Night Football game. So we had another power outage today at one of our other campuses, a PG&E problem.
Had a power outage the other day.
We need a smart grid.
I think it happens 5 times a year.
Yeah, you need a smart grid when you don't even have a regular grid.
A lot of buildings from the 50s, 60s, and 70s, suddenly you need electrical switching for just about every desk instead of one for the entire room.
A big load on the system. So this is the design that I came up with, and again, my role is kind of more like I'm like the network architect and systems architect of this. And this is the design I came up with now for our Chinatown campus, and then our Ocean campus, which is across the city. And we're fortunate enough we have a lot of fiber. We have a fiber network that spans the whole city. So we can come up. We did a dedicated SAN ring because you want 2 SAN nodes, kind of for redundancy anyway. But you also want your SAN to be close to the desktop, to the end user. So the latency gets to be a big issue. We haven't really experimented completely with that yet, but when you're expecting your data to come from the C drive, which is right there, and all of a sudden it comes from some distance away, we don't know quite what that implication is going to be. So the best design strategy, though, is to have the SAN nodes at the physical site. But now we've got 8 other campuses too, so I'm not sure if we're going to be able to replicate this model everywhere. We are doing it here because we need a backup business continuity site anyway. So we already have 2 SAN nodes. So it's an easy decision to put it here to support this new environment. And just dedicate the ring just for SAN, so we do a 10 gigabit ring just for the SAN nodes, because the SANs are chatting back and forth all the time, huge amounts of data, keep synchronized. And then we go through a SAN switch, and so here would be the SAN nodes, and then the Blade server environment, and then distributes out through our local area network into the rest of the building. And then that actually connects to the other campuses. So we have essentially a local area network ring, and it's in addition to a SAN ring. I should say a metro area network ring, in addition to the SAN ring. And then the LAN is within the building. So we're fortunate to have this fiber at our disposal to do that. Otherwise, I don't know quite how you would do it. You'd end up with isolated SAN nodes at each location.
Which have to keep synchronized.
Yeah, or they wouldn't be synchronized.
So they just
they'd be isolated.
Yeah.
You wouldn't have they've built in so much redundancy into the SAN nodes. I mean, drives can fail, and so, like I said, you end up with a lot of redundancy. So you do want this for a business continuity site. You want your ERP data spread somewhere else. So we use Iron Mountain as well, but to store the tapes offline. But you want some kind of a failover mechanism. So this is the design that I came up with for this particular site. So the 10 gig ring across the metro, that's kind of advanced. It's good technology. Look at it on my resume.
I'm curious if you have any numbers yet. Have you taken any traces and seen what the latency is, say your metro distribution switch?
Right now, you can ping anyone on our network in 2 milliseconds or less. Okay. Assuming there's no other weird OS things going on your desktop or whatever. But
so
yeah.
Any latencies at the application layer.
Yeah, right. So, or a slow DNS server can screw you up too. But yeah, as far as the distance goes, I mean, it's as if you're going from building to building. So we just go across the city. It's a small city, but so our ring is about a 30-mile diameter ring, roughly. So I translated this over kilometers because the optics that you buy are rated in kilometers, and this is kind of the max distance for a 10 gig, at least this scale. You can get much more expensive optics. If you have a 10 gig link over to Japan, or for example, they use almost like industrial grade lasers that are very expensive. But here it's still just kind of our standard plug and play modular equipment that we can easily support with chips and patch cords and things like that. So that's kind of and each one of these is, I think, maybe, we had about 4, and I think they might be maybe around $3,000-$4,000 each, something like that, the scale product. And it's just a module little thing. But then once you put it in place, I mean, this thing lasts for a long time. And so that gets to the objectives. So you really want an increased lifespan in the desktop, because granted, all these ROI models you see, they use 3 years, but nobody replaces desktops every 3 years. Maybe in 1997 when Y2K was coming out, but desktops last quite a while now. The quality's gotten better. If anything, you just can't keep upgrading to the latest version of Windows because it always wants more memory, and sometimes you max out your desktop capacity.
No money to do it anyway.
Yeah, or if you could save it XP or something like that for 10 years. So you got to try to squeeze max lifetime out of the PC itself, but the keyboards are pounded on and all kinds of things. So the whole goal here is using components that are going to give you that longevity. That so now your lab environment will last, let's say, 10 years instead of 5, or something like that. And then reduced application deployment. So like now, if somebody, our semester starts next week, and our deadline was November to tell us you need a new app ready for January, because it's a lot of time to do the image and all that stuff. So we really want to be able to cut that down to a couple days. If the instructor says, hey, I need this new app now, we want to get it out to 50 computers, next day. So that's the goal there, and that's lower support costs. And then with the Unidesk benefits, you just get better control over the image, which ends up being the most important thing. Reduce SAN storage, and then with the Blade server, we get more redundancy within the Blade environment, and then the scalable network interfaces. So those are improvements in overall with the DDI or the benefits, and then these are the new and improved iteration.
Very
I like
cool.
what the Facebook guy said, it's done is better than perfect, but you will improve it the next time you keep doing it over and over. So.
Well, that's really very interesting because, of course, yeah, the keyboard monitors, mouse, you don't need to go from 17 to 24. That's all in the last 7 years. And
Yes.
you need Win7 for CS5, and then you just provision an image and leave everything else on the XP image. It works great now.
So that was it. A few interruptions.
My question
You still got on there early.
Yes.
He recorded the whole time. I thought I turned it off.
Oh, we're going to have all kinds of comments.
you have a number.
Great, thank you.
Oh, right, I forgot about that. Coming back to see you guys.